Hey everyone, I'm Julian, the co-founder of Elusiv, and at Elusiv we are building a universal encryption layer for Web3. That basically means we encrypt transaction data to ensure your privacy and to avoid leaking sensitive financial data to the general public. So why should you care about privacy in the first place? Privacy is a fundamental human right recognized in the UN Declaration of Human Rights, the International Covenant on Civil and Political Rights, and many other international and regional treaties. The right to privacy in the digital world and access to privacy preserving technologies has become one of the most important human right issues of the modern age. Governments around the world constantly try to restrict our privacy by introducing new bills, often under the cover of protection for children or anything else they can come up with, for example, anti-terrorism or whatever. And that even though digital technology is very vulnerable to covert manipulation and surveillance. And I think that we can all agree that we don't want our behavior persistently monitored and exploited for commercial, political, or malicious purposes. And therefore, privacy by design is essential. It's important to recognize the limitations of a fully transparent blockchain. Institutional adoption, believed to be the primary catalyst for crypto adoption and crypto growth, um, is virtually impossible without privacy. Most businesses are unwilling and unable to conduct their financial operations on chain, resulting in a staggering 40 trillion US dollar in untapped potential just for B2B cross-border payments. Ensuring that DeFi remains free of manipulation is challenging as well, as practices such as copy trades or stop-loss hunting are widespread. Additionally, individuals are unable to selectively disclose their NFTs, and consequently, we all continue to reveal our sensitive financial information to the world, leaving us susceptible to digital threats like scams and phishing, as well as threats in the physical world. The need for privacy is unmistakable, and by implementing privacy features, we can introduce new use cases, expand existing ones, and as a result, increase the value of the on-chain ecosystem by several orders of magnitude. Therefore, you as a developer, when building your apps, should start thinking about how you can protect your users' privacy as well. Eventually, our SDK will offer an easy solution for this. But the question now is, how do we achieve privacy in Web3 without sacrificing security, safety, and decentralization? Because we currently have a privacy dilemma in Web3. As we just learned, blockchains by default are transparent, putting Web3 at risk for even worse data exploitation than Web2. Just to highlight this again, even a single on-chain transfer to a friend can potentially expose your entire transaction history, balance, as well as any future transactions to their view indefinitely, meaning you're permanently doxxed, and that's really bad. Therefore, we need to be careful that we don't build something worse with Web3 than we already have with Web2 and prevent heading towards an Orwellian future. The second problem we have is that current privacy solutions could be exploited for illicit purposes. In case you don't know, Lazarus Group, a North Korean hacker group, used Tornado Cash to hide their traces with hundreds of millions of dollars stolen from protocol hacks. At some point, the US government stepped in, and now the open source code of Tornado Cash is sanctioned by the US Treasury, meaning currently individuals in the United States are prohibited from legally using Tornado, even though most of the volume was and still is from honest users that just care about their privacy. However, as an immutable smart contract on Ethereum, the application itself continues to function. And lastly, to attempts to ensure safety and integrity within private systems has been reliant on centralized, so data exposing processes like KYC. Web3 is paradigm changing, creating a digital world that truly empowers people. But mainstream adoption won't happen without privacy. And therefore, we build a solution, and that's obviously Elusiv. And with Elusiv, you can send, receive, and eventually swap funds privately on chain at almost zero cost. You can integrate privacy as a feature with our SDK for any kind of application like wallets, DeFi apps, an NFT minting site, or any payment application. So please reach out to me if you're interested to integrate privacy as a feature into your application, because we make privacy programmable. And lastly, with Elusiv, you achieve uncompromised privacy through our decentralized compliance system. There are several parts to it, but the most notable and unique is something we call autonomous protocol analysis, a short APA. It basically allows to decrypt transactions of illicit actors in a decentralized way, and therefore removing them from the system by doing a multi-party computation, short MPC. Decentralization comes through a network of free layers, we call them the Elusiv wardens, that can eventually be run by anyone. And these wardens, on the one hand side, relay transactions for you to gain privacy in the first place, and on the other hand side, also do on and off chain compliance checks. A transaction can only be decrypted if the wardens reach consensus to a certain threshold that a specific transaction is indeed illicit. I'd say now it's time for a short demo. I want to showcase our web app here and make a private transaction to give you a better understanding of how Elusiv looks like and how the protocol works on a high level. It just went live on Solana a few weeks ago, so this is on Solana mainnet, but eventually will look the same for Sui. We use the Soulflare wallet in this example. They're also building a wallet for Sui called Ellie, so check that out if you haven't already. And yeah, just imagine we're on Sui using Ellie right now. So what we do first is to connect our wallet with the Elusiv application and sign this message to generate the Elusiv seed to basically see and spend our private assets. First thing we need to do is to top up our private balance. We currently have 10 USDC in our wallet, so let's top up 8 USDC to our private balance. After calculating the fees, we can click top up and approve the transaction. We can now see that we have 8 USDC inside our private balance, so let's send 5 USDC, click confirm send. Then now it's building the zero knowledge proof, and the transaction went through successfully. Great. Let's check out the transaction in our transactions tab. It displays our private send and top up transaction, and here we can also see a small part of our compliance system. We can generate a so-called VN key, copy and paste it into a compliance explorer, and now we can see our actual transaction and that we send funds to ourselves in this example. A use case for VN keys is, for example, In some countries, when you're doing your taxes, you can share a transaction with your tax consultant, or any other case where you need to like share like a private transaction, you can do it with a viewing key. And you might have also noticed that the fees for this transaction were actually paid in the relevant token, so in this case in USDC. So how does Elusiv actually work? Well, it's all ZK magic. Let's dive quickly into what happened under the hood. In order for a user to send funds, the link between the sender and recipient needs to be broken. Hence, we split the transaction into 2 steps. The first step consisting of generating a private balance. The generation of the private balance happens in the Elusiv smart contract. In short, the user stores funds in a pool controlled by the smart contract, where it keeps track of each user's spending authority. For a user to spend their private balance, they need to prove spending authority. Spending authority is generated using a hash-based commitment scheme. This cryptographic scheme allows a user to commit to a value and hide it with ability to reveal later when one wants to spend the funds. The commitment includes the amount, the asset type, and nullifiers. The nullifiers is the second part of this cryptographic scheme, a secret value only known to the user. When they eventually want to spend the funds, they prove ownership of the nullifier to open the reciprocal commitment by generating a ZKP. Although complex under the hood, this is similar to how a UTXO-based system works. All right, that's pretty much it from my side. For future updates, please join our community, follow us on Twitter, and join our Discord. One important point to take away from this keynote is that privacy is normal, and that if you want on-chain privacy for your transactions, you should use Elusiv. And yeah, don't forget to grab some swag. Thank you very much.